Alright, welcome to the start of week 5, lesson 1. This week we're gonna actually solve problems involving probability of independent events. You did this last week, but last week you created a sample space to help us determine the probability of independent events. This week we're going to generalize and apply a rule for determining the probability so that we don't have to draw a sample space all the time. Okay, as a resource, you're going to use this video to follow along the lesson. Okay, for extra explanation on this, there's a YouTube link here as well. For extra practice, you can use your math workbook 7.3 and 7.4. Also, you can email your teachers whenever, and we'll get back to you as soon as we can. All right, so let's look at a question from last week's task. Okay, you had a question where you had a spinner and a die that's four-sided. Okay, one of the questions was, what is the probability of the pointer on the spinner landing on red? So the mathematical expression we use is P of red. Okay, out of the 3 colors, there's 1 chance of getting red, so our answer was 1/3. What is the probability of rolling a 3 on a die? It's a 4-sided die, so there's 1 chance out of 4 sides that's gonna give us a 3, so it was 1/4. What is the probability of spinning a red and rolling a 3? Probability of red and 3. Okay, again, this is an independent event because what I get on the spinner does not affect what I'm gonna get on the die. Okay, and when you listed the sample space of all of this, okay, you probably got to the answer 1/12. Okay, when we compare these answers, what do we notice? Is there an easy way to determine the probability of independent events instead of making a sample space? Remember, a sample space would be something like spinning a blue and then rolling a 1, blue and 2, blue and 3, blue and 4, or spinning a green and rolling a 1, green and 2, and so on and so forth. Okay, that was a sample space that we had to make for last week's lesson. Okay, but for this week, we're gonna notice that to get probability of red and 3, we actually are just multiplying this and this together. Okay, so we go 1/3 times 1/4 is equal to 1/12, and that was our answer here. Okay, therefore, we can say that probability of red times probability of 3 gives us the probability of getting a red and then a 3. Okay, so we're gonna use this now to solve this example right here. Okay, example number 1, what is the probability of spinning pink and then a purple? So probability of pink and purple. Okay, looking at spinner number 1, probability of getting a pink is, there's 2 pinks out of 4 spaces. Okay, and then we're gonna multiply by getting a purple on spinner 2. Okay, and that's just 1 out of total of 3 colors there. Okay, so we're gonna multiply 1/3, and we get 2/3, like this. Okay, what we could have done is, what I should have actually done is, 2/4 can be simplified before we multiply, right? So let's simplify this to 1/2, and then we get 1/6. So the probability of spinning pink and then a purple, so probability of pink and purple is equal to 1/6. Okay, because we multiply the probability of getting pink, which is 2/4, reduced to 1/2, and times that by probability of getting a purple, which is 1/3. Okay, and our final answer is 1/6. Okay, isn't this so much quicker than creating a sample space? All right, let's look at our next example. What happens when there are more than 2 independent events? So instead of just doing 2 things, we're gonna do more than 2. So let's say we flip a quarter, a dime, and a nickel. There's 3 different events. They're all independent of each other. Flipping a heads on a quarter isn't gonna affect what I'm gonna get with the dime, and that's not gonna affect what I'm gonna get with the nickel. That's why these are independent events, okay? What is the probability of getting all tails? So probabilities of tails, tails, tails. If we were to do this using a tree diagram, I have one right here so that you don't have to draw one. Okay, if you use a tree diagram, it looks like out of 8 possible outcomes, our favorable outcome, so tail, 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 is 1 out of that 8. So our probability of getting 3 tails is 1/8. Okay? Notice how to get to 1/8, we go 1/2 times 1/2 times 1/2. This 1/2 represents the probability of getting tails on the quarter. Probability of getting tails with a dime is also 1/2. Probability of getting tails with the nickel is also 1/2. When we multiply them all together, we get 1/8. Okay, so same thing with more than 2 independent events. We're gonna multiply, okay, each of the probabilities together. Okay, so let's look at this question over here. A coin is flipped. Okay, a spinner divided into 3 equal regions is spun, and a 4-sided die numbered 1, 2, 3, 4 is rolled. What is the probability of getting heads, and then a red, and then an even number? Okay, so to solve this, we're gonna multiply probability of getting heads times probability of landing on the red times probability of rolling an even number. Okay, so let's look at what is our probability of getting heads on a coin. That's going to be 1/2. What's the probability of getting a red on the spinner? There's 1 red out of 3 colors, 3 equal sections here, right? So we're gonna go 1/3. We're gonna multiply by probability of getting an even number. A dice has the numbers 1, 2, 3, 4. So there's total outcome of 4, and there are 2 and 4, 2 even numbers. 2 and 4 like this. Again, I can reduce this to 1 and 2. Okay, now when I multiply all the numerators together, I get 1. All the denominators together, I get 2 times 3 is 6. 6 times 2 is 12. Okay, so our probability of getting heads, a red, and an even number is 1/12. Okay, I'm gonna go over one more example. Okay. All right, example number 2. Carter decides to guess his answers for the last 3 questions on his learner's test. Each question is a multiple choice question with 4 different possible answers. 4 different possible answers. What is the probability of him getting them all correct? Okay, first of all, Carter should not be guessing on multiple choice questions. Okay, and now we're gonna look at his chance of getting them all correct when he does decide to guess. Okay, so in our question it says there are 3 questions that he's gonna guess on, and each question has 4 different possible answers. So we're looking at probability of getting it correct, correct, and correct. Okay, so probability of getting it correct on the first one times probability of getting the second one correct times probability of getting the third question correct. Okay, out of 4 questions, there is only 1 correct answer, so his chance of getting the correct answer on the first one is 1/4. Second question, because these are independent events, is also going to be 1/4. And the last third question is also going to be 1/4. Okay, so this 1/4 represents that he has there's 1 correct answers out of the 4, so if he's guessing, he only has 1 out of 4 chance of getting that question right. And he's gonna guess on the last 3 questions, so we're gonna multiply 1/4, 3 1/4s, okay? And when we do that, we get all the numerators multiplied together gives you a 1. All the denominators multiplied together gives you a 4. So 4 times 4 times 4 gives you, what is this, 16 times 4? 64. Okay, so Carter has 1 out of 64 chances, 1/64, okay, probability of getting all the last 3 questions if he decides to guess his answers. Okay, so instead of guessing Carter, maybe you're going to study for this test so that you increase your chances of getting this correct. Okay, 1/64 in percent is, let's grab a calculator, 1/64. This is 1.56% that he'll get the last 3 questions right if he guesses, okay? So no guessing, Carter. All right, so that is the lesson for this week. Okay, now you guys can go ahead and work on your week 5 task 1. Make sure to take a picture of it when you're done and submit it on D2L. Bye guys.